So hello everyone, this session I will cover the Perceptron technique. So like your logistic regression, Perceptron is also used to solve the classification problem. The only difference between the Perceptron and logistic regression is in terms of sign function, sign versus sigmoid function, and the loss function. In the logistic regression, we use the sigmoid function to calculate the probability of the class for the given query point. But here in the Perceptron, only we use the sign function. A perceptron, in fact, is normally trained by minimizing the mean square distance between the actual value and the predicted value. So like your logistic regression, here also we use this equation of the hyperplane z equal to wx plus b. So here my z will represent the predicted value. So my y is equal to 1 if we are getting z is greater than 0. If z is greater than 0, then my y will be classified as the 1. And if z is less than equal to 0, my y will be 0 here. This is the example of binary classification problem. And in the perceptron, the loss function is defined by this equation. L is equal to 1 upon n, summation of all the differences. Here the differences I can calculate it using L2 norm, that is my yi minus yi cap, that is expected minus predicted value. Again, this loss function is similar to the other loss function. Yeah. And here, the stochastic gradient descent algorithm is an optimization algorithm technique where we pass the perceptron, we pass as a loss function. So that we will discuss in the next slide. Now, I will discuss here perceptron misclassification problem that can be solved using the gradient descent problem. So for that, we are assuming this data set. So one of the feature of the Python programming language is what we can create the dummy data set. So here is the Scikit-Learn code for creating the dummy data set. So if you want 500 samples that you want to split into the two classes, for example, 0 and 1. So here is the code, Scikit-Learn code from a sklearn.dataset import make classification. So make underscore classification is an inbuilt function that you can use to create your data set. And number of samples you want is equal to 500 that you can pass as a parameter to this make classification function. So x comma y equal to make classification, we create the data set with the n number of samples. Here my n is nothing but the 500 number of features that you want is 2 here because you want to implement here the binary classification problem, right? Then this make classification will create this data set. You can observe here, if you visualize this data set, your data set will be like this. Blue color indicate all the class 1 data points and the red is the class 2 data point, for example. Now, how your perceptron mix classification problem can be solved using the gradient descent problem. So what is gradient descent here? So gradient descent is nothing but the optimization algorithm. Optimization means what? We want to improve the accuracy of my model, or in other words, we can say we want to reduce the loss function. So it is used to update the weights in case of misclassification. It does this by using the loss function, and that tells us the loss in case of misclassification. So gradient descent minimizes the cost function by gradually updating the weight values. So by trying the different values of weight values, you can find the optimal value. So definitely my algorithm works in the number of iterations. And in every iteration, we pass the different value of W. Right? And my objective is to find out the optimal value of the W here by using gradient descent technique. So here, my sample is said to be misclassified if this calculation y into x into w is less than 0. Actually, it should be positive because my class is positive here. My class is 1 here. right? Positive here. So if this calculation y into x into w is giving you the negative value, actually it should be positive, or this calculation, that is minus y into x into w, is giving you the positive value, but it should be negative actually. Then this is the misclassification condition. This is the example of the misclassification condition, and my objective of this gradient descent technique is to avoid these misclassification techniques by trying the different values of the weights in the number of iteration. So here is the formula, right, for calculating the updated weight, right? So how my stochastic gradient descent algorithm works, right? So here in the Python also inbuilt class is there, that is SGD classifier, which is defined under the Scikit-Learn library. So also we will discuss here the Scikit-Learn code for this SGD classifier. So the idea behind this stochastic gradient descent is iterating a weight update based on the gradient loss function. Iterating a weight update based on the gradient loss function. So how you can update this weight? So here is the formula. Wk plus 1 means the value of the next w, the value of the w in the next iteration will be is equal to the previous weight value minus gamma into delta into loss function. The same function we can rewrite here in the simple word. W is equal to W minus alpha into delta, where W represent the coefficient that or weight that being optimized. Then alpha represent here learning rate. For example, here 0.1, this alpha acts like a alpha penalty term alpha in the regularization technique, and delta represent here my loss function or error. And this delta value is nothing but D equal to Pi minus Yi, where Pi is the predicted value and Yi is the expected value. So how this alpha and delta will help you to update this value? Actually, the alpha and delta value only will help you to update the value of the W in the next iteration. So here is the Scikit-Learn code for the stochastic gradient descent with the Perceptron loss function. So from sklearn.linear model, import SGD classifier. So SGD classifier is the inbuilt class for this classifier, stochastic gradient descent classifier. Here we are creating the object of this class. SGD is the my variable name, object name. Here in this SGD classifier, we need to pass the loss function, because SGD is an optimization problem of optimization technique. Here we need to pass the method to calculate the loss function. So here we are using Perceptron method for the loss function, for example, right? So this loss function technique we are mentioning here as a parameter. Then learning rate is my what alpha value is one of the parameter we need to pass here in the SGD classifier, which is said to be optimal. So optimal value will be taken by this SGD classifier, and also we need to mention here number of iterations. So how many times you want to change here the value of W. So 10 different iterations will be execute. This SGD classifier will execute 10 different times, and 10 different values of the W will be calculated by this SGD classifier, and the optimal value will be written by this SGD classifier out of these 10 values. So cross-validation score we can use here to measure the accuracy of this SGD classifier. Here the parameter that we need to pass is the object of my classifier, which is SGD, then X and Y my data set, right? And scoring function. So how we want to measure the accuracy of your model by using accuracy here. If you want to measure the accuracy using precision recall, then you can change here precision recall. Here I want to use the accuracy scoring function, and that's my value that is assigned to this parameter is the accuracy here. And number of fold that you want here is the 10, for example, right? And mean value will return the mean of all these 10 different values of the cross validation score, right, to obtain the average accuracy. So this is the accuracy we have obtained for this dummy data set that we created with the two class labels, right? With the 500 samples, right? So I hope students you are clear with this. Here we have used the SGD classifier to optimize the model. The same result we can obtain by directly using the Perceptron class. So alternative solution is there. So instead of using SGD classifier, we are passing the Perceptron loss function directly. You can use here the Perceptron inbuilt class that is also available in the Scikit-Learn library. So from sklearn.linear model import Perceptron, then create the object of this perceptron, then pass number of iteration here, right? Again, my objective is to find the optimized solution. So this perceptron algorithm will run in the 10 different iterations, right, to find the optimal solution. And again, if you check this result of the cross validation score, right, with the perceptron object and xy my data set, same data set and scoring function accuracy with the 10 different folds, again you are getting the same result here, that is 0.98, means 98.59%. Right, my accuracy is little bit different here, but here it is near about the 98%. I hope you are a student, you are clear with this perceptron technique and stochastic gradient descent problem. So in the next session, we will discuss how to find the optimal hyperparameters through the grid search algorithm. Thank you.